In this lesson, we're going to talk about graphing exponential functions, and we're going to use a calculator to help us investigate some of the values for our exponential function um, when they get very large or very small, but some of them we can do without a calculator. Um, so when it's talking about graphing calculator and using the ASK mode, it's talking about the TI. So if you have your TI app, you may want to try that. I'll use a handheld for the problem section where we need a calculator. So what we're doing here is using y equals 2 to the x power as our parent function. And we're just going to plug some values in for x. X is in our exponent. So if I put 0 in for x, 2 to the 0 power, 2 to the 0 power is just 1. And then if I put in 1, 2 to the first power is 2. 2 to the second power, 4. 2 to the third power, 8. 2 to the fourth power, 16. 2 to the fifth power, 32. And then we get to the ones where we might need a calculator. So, some of those you didn't see. So now we have 2 to the 10th power. So this is where you may want to do what it's telling you on your calculator app. So let me remind you guys how to do this. We're going to go to y equals and put in our equation 2 to the x power. And then we're going to put it in ASK mode. So go to second window. And we're going to go down here to where it says independent, arrow over to ASK, hit enter. And then go to second graph, which would give us our table. And the table is going to be blank. So we can put any values we want in there. So here's 10, hit enter, and we get 1024. All right, and then we have 2 to the 30th power. So I put in 30, and I get 1.07 E9. 1.07 E9. Let's talk about what that means. E9 means 1.07 times 10 to the 9th power. That's a lot of zeros added on to the end of that. Getting very, very, very large. And so 2 to the 50th power, it's E15, a lot more zeros. So 1.1 E15, or 1.1 times 10 to the 15th power. Very, very, extremely large. All right, then we're going to do the same thing over on this next column. When I put in -1, 2 to the -1 power, we talked about that. That's going to flip this over to 1 over 2. 2 to the -2 power would be 1 over 2 squared, or 1 over 4. 2 to the -3 power, 1 over 2 to the third, or 1 over 8. 2 to the -4th power, 1 over 2 to the 4th, 1/16. I think you see a little pattern going on here. So 1/32nd, 1/1024th. But then the ones that we definitely are going to need a calculator for, 2 to the -30th power. So -30 gives me 9e -10. 9e -10. Or 9 times 10 to the -10th power. So that's a lot of decimal places. 0.0000, a lot of zeros before we get to that 9. And then the same with the -50th power, even smaller, 9e -16, or 9 times 10 to the -16th power. So getting very, 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 very close to 0. So what it's saying here is that as x gets very large, going towards the positive values, that's this column, what's happening to y? Well, y is also getting very large. As x goes in the negative direction, though, y gets close to 0. So whenever we have something going close to infinity and the other value getting close to 0, there is an asymptote, so there's going to be a horizontal asymptote. Where y equals 0. Alright, so they want us to sketch this function, so we're just going to use these values that we've got in our table and plot them. So we have 0, 1. That is a very important point. I want to make that one really big. And then we have 1, 2, 2, 4, 3, 8. And that's about all that will fit that direction. And then we have -1, 1/2, -2, 1/4, and we're getting so close to the line that we really can't draw much else. But we know that we're getting really close here. This is our asymptote line, right? Our horizontal asymptote is at 0. All right, so that's the graph of 2 to the x power. So let's talk about some of the characteristics of this graph. If we look at this graph from left to right, this graph is an increasing graph because as x gets larger, y gets larger. As x approaches infinity, y approaches infinity. Our domain for this function is all real numbers. It's going to the left, it's going to the right, so our domain, all real numbers. Our range is going to be everything greater than 0 but not equal to 0. So 0 to infinity, or y is greater than 0. Also, I pointed out to you this 0, 1 point right here. That's going to be very important. It passes through the point 0, 1. Alright, so on the back, we have this as our parent function, which is y equals 1/2 to the x power. So instead of using 0.5, for the ones that I do without a calculator, I'm going to use 1/2. So if I have 1/2 raised to the 0 power, anything to the 0 power is 1. 1/2 to the first power would just be 1/2. 1/2 to the second power means that I'm going to square the 1 and square the 2. So 1 squared is 1, 2 squared is 4, so I have 1/4. 1/2 cubed, I'm going to cube both of those values, so I get 1/8. 1/2 to the fourth power, 1/16. 1/2 to the fifth power, 1/32. You may recognize these numbers. These look very similar to the numbers that you had on the other side of the paper. So if we're using that information, you might remember the 1024 that we had before. This is going to be 1/1024, or you could use your calculator to do the decimal. And I'm going to go ahead and use the calculator for my 30th power. So I need to go to y equals and put in my function. So 0.5 raised to the x. And now I'm going to go to my table. I'll delete all of these that are in there, and we're looking for 30. So 9e to the -10. Remember what that means. Very, very small. 9 times 10 to the -10th power. So it's getting close to 0 on this column. And then the 50th power, 9e to the -16th. Or 9 times 10 to the -16th power. Alright, so over here on the other column, I've got 1/2 to the -1 power. That just means that I need 1 to the -1 power would go to the bottom to become positive, and the 2 would move to the top. I just get 2/1, or 2. 1/2 to the -2 power, we're just going to flip those over, and this exponent becomes just 2. So 2 squared would be 4. And the same with the -3. We would get 2 cubed, 8. And then you see the pattern again. And these are going to be the same values we had on the other side of the page as well. Whenever you raise this to the negative 30th power, we get the 1.07 E9, or 1.07 times 10 to the 9th power. And when you put in negative 50, you get 1.1 E to the 15, or 1.1 times 10 to the 15th power. So now it's this column of y that's getting very close to 0. So as x approaches positive infinity, y approaches 0. And as x approaches negative infinity, we're just getting larger and larger for y values. But there still has to be a horizontal asymptote where y equals 0. It's just that this time it's coming from another direction. So let's plot the point so we can see what I'm talking about. We still have that point 0, 1. So I'm going to plot that one. That one is the important one, and it's important because that's the same point on both of these graphs. But the other points are going to change a little bit. So at 1 we have 1/2. At 2 we have 1/4, and that's about as close as we can get. On the other side at negative 1 we have 2. Negative 2 we have 4. Negative 3 we have 8. So this graph looks a lot like that other graph, except it's reflected across the y-axis. So this graph, read from left to right, would be decreasing, because as x gets larger, y is approaching 0. As we go to the right, from left to right, as x gets larger, y approaches 0. All right, our domain is still all real numbers. Our range is still 0 to infinity, or y is greater than 0. And this still goes through the point 0, 1. 0, 1 is going to be important for us when we're shifting these graphs. So, something that I want you to notice is that in this graph, our parent function was a fraction raised to the x power, and the graph was decreasing. On the other page, of the other side, our parent function was 2 to the x power, where the base of this was a whole number, a number greater than 1. And as long as this number was greater than 1, our function was increasing. And so that's the connection here. This base value is greater than 1, the function is going to increase. The base value is a number between 0 and 1, a fraction between 0 and 1, the graph will be decreasing.